Okay, year 9, question set 12. Who would have thought it? So here we go. We got some surds that we need to simplify. We got some rationalizing of denominators to do with surds, some surds to expand there and simplify. Bit of foiling maybe on that one. So you got 5 minutes starting now. Remember my hint, look for the square numbers hidden inside those surds so you can take them outside. Square numbers. That's it. Time's up. Let's have a go. All right, root 80. I'm going to show you two ways of doing this. Because now, if you're good with your 16 times table, or just happen to notice that 80 can be made from 16 times 5, then great. You can go straight to the answer straight away. Also, remember, we're looking for those square numbers. 1 is 1, 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, etc. Okay, so we want those square numbers. We want to try and find a way of making this from a square number. Well, there's the 16. And if it's times together inside a square root, you can take it outside. And well, that should be a 5. And write it as two separate square roots multiplied together. That was from our sort of surd rules. And of course, the square root of 16 is 4. So it's actually 4 root 5. 4 times root 5, basically. Like 4x, we don't put the times, it's just 4 root 5. That's why we're trying to find those square numbers, so that you can take it outside and square root it into a normal number. And of course, you might not have noticed that, in which case you might go, okay, I'm going to play it safe. 80 definitely divides by 4, which is also a square number. So I could do root 80 equals 4 times by 20, isn't it? And then you could take the 4 outside in its own square root and turn that into 2, because square root of 4 is 2. So you'd have 2 root 20. And then you might notice that actually, hang on, 20 can be split up as well. And so you could do it in 2 steps. 20 is made from 4 times 5. So you end up with 2 root 4 times by root 5, because you separate these two into 2 separate square roots. And of course, root 4 is 2. So that turns into 2 times 2, which is actually 4. Okay, so you could do it in steps. If you're not sure, do it in small steps. But if you notice that it's 16 is sort of hidden in here, 5 16s are 80, then you could do it straight away. Either that way is fine. Notice you still get to the same answer. No problem at all. Next, simplify these. Okay, so we want to add them together. We're going to fully simplify them first to see if they've got the same surd hidden inside them, that irreducible square root. 27 can be made from 9 times 3. 9 is that square number. That's a 3. And 12 can also be made from something times 3, 4 times 3. Okay, so that I can see where I'm heading with this. Root 9 times by root 3 plus root 4 times by root 3, because we'll separate them into separate square roots. Remember, always looking for that square number hidden inside there. Root 9, well, square root of 9 is 3, so that's 3 root 3. And the square root of 4 is 2, so 2 root 3. And then you can add them together, just like you would with, what do you call it? You know, like 3x and 2x would make 5x. It's exactly the same here. 3 root 3 and 2 root 3 makes a total of 5 root 3. 5 lots of root 3. Rationalize the denominator. Denominator is the thing at the bottom of a fraction, obviously. Times it by itself, essentially. Now, you could times it by 2 root 3, but you'd have to do some simplifying later. It's actually good enough just to times it by the surd. Now, of course, if you times the bottom of a fraction by the surd, you also need to times the top of the fraction by the same thing. Times the bottom and the top by the same thing. And to rationalize the denominator, just times it by that surd. Okay, 1 times root 3 is root 3. 2 times root 3 times root 3. Let's write this out in full, actually. 2 times root 3 times by root 3 is what that is. Let's put a little thing in there so we know which bit of the question we're working on. Should have done it in a different colour. The top is root 3. Now the bottom here, root 3 times root 3. Remember what happens when you times the surd by itself? Let's put it over here. Root 3 times by root 3 equals 3. Yeah. Try it on a calculator, it does. So root 3 times root 3 is 3. And then we need to times it by the 2, because we've got 2 lots of that. So root 3 over 6. Just times the top and the bottom by that root. Let's change colour so that we know what's going on. Right, expand and simplify. The expand bit is foiling. First, outers, inners, and last. So first, root 7 times root 7, just like it was with the 3s. this turns into 7. Outers, root 7 times by negative root 3. Well, that's minus 3 lots of root 7. You treat them just like you do your algebra. 3 lots of root 7 is 3 root 7. Inners, 2 lots of root 7, which is positive, and lasts 2 times 3, but it's 2 times negative 3, so negative 6. And let's tidy up. 7 take away 6 is 1. Negative 3 lots of root 7 plus 2 lots of root 7 is a difference of negative 1 root 7. But we don't write the 1, just like algebra. We don't put 1 root 7, we just put root 7. So it simplifies to 1 take away root 7. Okay, FOIL it. Rationalize the denominator on this one. Now this one is trickier. I can't just times it by root 3. If I did, the root 3 times root 3, sure, that turns into a proper number, but the 4 times the root 3, which I'd have to do as well, because I'd have to multiply both of these bits by root 3, that would just turn into 4 root 3. I've still got a surd in the denominator, so I have to do something different here. I times it by what we call the conjugate. Now it's the same numbers there, so root 3 and 4, except we change the sign in the middle to the opposite. So instead of take away, it's plus. And if this was plus, we change it to minus, right? And through some magic, there'll be a bit of cancelling out in a second. The root 3s will disappear. The surds will disappear. But of course, if we times the bottom of a fraction by that, we need to also times the top of the fraction. 1 lot of root 3 is root 3. 1 lot of 4 is 4. Right, so the top is done. Happy days. Now the bottom, I need to FOIL. And I'm going to do it over here separately. There's a bit of working out so it doesn't clutter up my answer over here. You could do it as part of the answer, but I think it sort of makes things a little bit cluttered, kind of hard to see what's going on. Right, FOIL it first. Root 3 times root 3 is just 3. Outers, root 3 times 4 is 4 root 3. Inners, minus 4 times root 3 is minus 4 root 3. See what's going on? We've got these two things that are going to cancel out, plus 4 and minus 4. And then last, minus 4 times plus 4 is minus 16. Right, plus 4 root 3 and minus 4 root 3, they cancel out and disappear. So we're left with 3 take away 16, which is negative 13. So that will be the bottom of my fraction over here. So it will be negative 13, but we don't like doing that. You can actually just put the minus in front of the whole fraction there. So root 3 plus 4 all over 13. Okay, I'll just give you an alternative answer to that because you might have written it a different way. So, or you might have done root 13 and made these negative. You might have done minus root 3 minus 4. Like that. Okay, that would just be just as good. Don't forget to mark correct. If you're not sure about surds, find a bit of time on Dr. Frost because no doubt you'll finish the lesson early if you skip through the video, which of course you don't because you're good. But if you did, you could go to Dr. Frost, click on practice, and then choose number and surds. Choose surds and practice those. Okay, right, well done. I'll see you next time. Bye bye.